So the value of a truck has been decreasing by 9% each year since it was purchased new. After 4 years, the truck is estimated to be worth $27,350. Find the purchase price of the truck to the nearest cent. So this is going a little backwards. So they tell you after 4 years, right, that the truck is worth $27,350. So they want to know the initial. They want to know the initial principal amount. So 9% each year. So we have our percentage. So 1 minus 0.09 for 9%. And then they tell us it's 4 years. So after 4 years, at a rate of 1 minus 0.09, it's estimated to be worth this much. So find the purchase price of the truck. So how much was it originally cost, basically? And so you're just going to go ahead and divide this over to the other side. Divide it over to the other side. Divide it over to the other side to get your answer. Yeah, not too bad. You just had to understand what it was asking you to do. So let me plug it into our calculator. And we go 27350 divided by parenthesis 1 minus 0.09 to the 4 power. And there we go. So we got, let me see here. Yep, 3983.36. There we go, so 39. So we have the principal is equal to, so we divided that to the other side. So principal equals 39,883.36 cents is our answer. That's our answer. Nice. Okay, so then let Y represent the mass in kilograms. Losing my voice, so no. Of radioactive material whose half-life is 3,200 years. There's our formula, CE to the KT. We just learned this, so hopefully you should do this on your own. Pause me. You got this. You just learned it. Try it on your own. Okay, so suppose there's 20 kilograms of element present initially, set up a formula, and solve for the rate of decay. All right. Well, let's see here. We got Y equals CE to the KT. So we know that the time, so the time is going to be 3,200 years, and that's half-life. So half-life is kind of basically here to here. So maybe, let's say that you have 1 gram or 1 kilogram, okay? Suppose there are 20 kilograms of element present initially, set up a formula to solve. Okay, well, let's say we do have an initial of 20, right? E to the KT, which is 3,200. And they want to do half-life. So half-life means what's half of the initial? What's half of 20? So the half of 20 is 10, okay? So half-life of 20 is 10. So now we're just going to solve for K. So we're going to divide 20 to the other side. And that goes away. So now we do have 1/2 is equal to E to the K times 3,200. How do we undo E? Do you remember? We ln both sides. Way-o. And so then we just have to divide by 3,200 to the other side. So ln of 1/2 divided by 3,200 is what we're looking at. And that's what K equals. So we plug that into our calculator. And we get ln of 1/2, right, divided by 3,200. And so that's going to be negative 2.16608. So 3 decimal place accuracy. And so we'll write the answer first. So negative 2.166. Negative 2.166. So that's basically E to the negative 4, or times 10 to the negative 4. And then store the actual computed value on your calculator. So that's going to basically be, the actual is actually going to be, so you have to move it 4 decimals 4 decimals to the left. To the left. So we're going to go 1, 2, 3, 4. So that's a 0, a 0, and a 0. So negative 0.000266. Okay. So write an exponential function for the amount of the radioactive element present in t years using the, so now just plug it in. So y equals c e to the negative 0.000266 times t. Now, using a window of 0 to 1,000 years and 0 to 20 kilograms, graph the exponential equation, use the stored value of k, and entering the equation on your calculator, label both. So now I want you to graph it, and then I want you to answer a question, and answer a question. So we go to y equals, and we go ahead and graph this guy. So, and using 0 to 20 kilograms. So our initial then must be 20, okay? So y equals 20 with the e there. That's second division I just did instead of the other one. To the negative 0.000266, close parenthesis, times x. You can put the x in the parenthesis, I don't know. And then we push graph, and it doesn't work, so we have to go to window. It says that our window is years is going to be, let me see, so 0 to 10,000. So 0 to 10,000, and then the 0 to 10,000, and then the y min and y max is 0 to 20 years. I feel like that's reversed. Why is that reversed in my head? So we're going from, oh yeah, that's the base. So we're putting, that's supposed to be x basically, is that, so that's years. Yeah, so I feel like that needs to be swapped. I don't think that's going to work. Oh, I guess it did. I feel like they got that wrong, but anyways, it worked. Yeah, I think they meant to say, anyways. So graph the exponential decay equation in the box on the right using the known values of c and k. So c is 20 and k is our exponential. So we push trace. And so do you remember where we start off at? For 20 kilograms, wasn't it like 3,200? I think it was 3,200 years, wasn't it? Let's see. So way up here at 0.20. So 0.20. Let's double check we're doing this right, actually. Yep, I think so. So there are 20 kilograms initially, and then a half-life after 3,200 years. So it's going to take 3,200 years for that to cut in half to 10, basically. So if we trace to the right, it should be 3,200 when y equals 10. Because that's the half-life. So y equals 10, and there it is, 3,200. Kind of. Yeah, there it is. Okay, good. So second calc at x equals half-life of x. We get 20. And then second calc, when we're doing our value, and we're saying when it hits 3,200, we're at 10. Looks good. So it looks like a really good graph. So we graphed on like this. We do have a horizontal asymptote of 0. So this is 20, this is 0. And so right about here, so our half-life at 3,200 years, then we have 10 grams now. Now we have 10 grams. This was 20 grams, and now we have 10 grams. Nice. Okay, so then use the stored value to answer these questions. How much does the element roll remain after 10,000 years? So we're going to go to the right and just go all the way to 10,000 years. So at 10,000 years, at 5,000 we're at 7. At 10,000 years, what are we at? What are we at? How much of the element is left after 10,000 years? So 10,000 years is 2.2927. Let's see, does it say one decimal place accuracy? So 2.29. So y equals 2.29, which one decimal accuracy would be y equals 2.3. So when x equals 10,000, y equals 2.3 is our answer. how many years would it take for 8 kilograms of the element to remain? So basically, you're going to go backwards to 8 kilograms to find the years. If you want to be really, really accurate, you would actually graph y equals 8. If you want to be really, really accurate, you would graph y equals 8. Ready? So go y equals 8 element. We push graph, and then we do the intersection. So there's our intersection. So we go second calc, intersection, enter, enter, enter. So 4230.335, or just 4230.3. So 4230.3. So when y, which is equals 8 kilograms, x equals that many years. There we go. Woo! Okay, there we go. So last but not least is just using the calculator one more time. And just doing the same thing and answering lots of questions. So try plugging that in on your calculator there. And give you that one to try. You can ask about it in class if you want to. Same with the inverse. So the inverse, I'll do another video for that next year because I think this year we're taking a break from inverse. And so we'll have a video of inverse and coming up. And it's basically, inverse is just switching the x's and the y's. And we already taught you that, so you do know how to do it. So, but maybe I'll do one more video and show how to do it. That'd be fun, right? Thanks for watching. Thanks for watching. Bye for now. Ace the test. Whoa, inverse. This year? Maybe. Last year? Next year? We'll see. Watch and learn. If we did 6.4, then we're going to include this on the test. If we didn't, then we probably won't. We'll see. Maybe it'll be extra credit. Maybe it'll be an easy one. Switch the x's and y's and solve for y. So let's take a look there at our practice test to finish this off. So averaging type words per minute. Use your graph calculator for the following questions. Find the number of weeks class to 30 times 700 words. How fast should a person be typing if they've been in class for 20 weeks? What's the linear number? Words per minute? Yeah, so I want you to try that one on your own. You got to try one of them on your own. Come on. So now inverse. So to find the inverse, you are just switching. You are just switching the x's and y's and solving for y. And that's it. Right? So if this is y equals the square root of 3x minus 5 over 4, then you're going to switch them. You're going to switch them. So now the y becomes x equals the square root of 3y minus 5 all over 4. And now you're going to solve for y. Now you're going to solve for y. So then you go ahead and times by 4 over to this side like that. Then you power to both sides. Distribute it, distribute it. So 16x squared is equal to 3y minus 5. Then you add 5 over to the other side. So we have 16x squared plus 5 equals 3y. And then you divide by 3. And so there's our new function. There's our new function. So switch the x's and y's and solve for y. That's how you find the inverse. That's how you find the inverse. So this one is y equals x plus 5 to the third power. And then we switch. And then we switch and solve for y. So x equals y plus 5 to the third power. So now you're going to cube root both sides. So the cube root of x equals, that cancels, y plus 5. And now you just minus the 5. So now we get y equals the cube root of x minus 5. That's the inverse. Pretty easy. Not too bad. That's the inverse. Pretty easy. So now it says to graph the function its inverse and a dashed line in between. Yeah, so we just choose some values to the left and to the right. So let's make this a nice, even, perfect square. Right? So what? 0 would be a good one, because if you plug a 0 in, then you get the square root of 0 plus 4 is the square root of 4 is 2. Maybe a 4 in there would be good, because no, 4 plus 4 is 8. Maybe a 5 would be good, because 5 plus 4 is 9. And the square root of 9 is 3. Square root of 9 is 3. And then what's another one? What's another one? Maybe make it go to 0. So in the square root of 0, the square root of 0 is 0. So we get negative 4, 0. We get 0 up 2. And then over 5 up 3. Nice. So that is that's the square root of x. Oh yeah, it's just the square root of x, but shifted left 4, right? Shifted left 4. And now we have to do the inverse. So to find the inverse, we go y equals the square root of x plus 4. We switch the x's and y's, so that's x equals the square root of y plus 4. Then we go ahead and power 2 both sides. So then we get x squared is equal to y plus 4. And then we minus 4 to the other side. So we get x squared minus 4 is equal to y. And so that's just a parabola that's upside down. No, it's not a parabola that's upside down. It's a parabola that's shifted down 4. That's just a parabola shifted down 4, basically. Right? Shifted down 4. Shifted down 4. Here we go. And so that's going to be down 4. So you can plug in value like 0. And 0 squared is just 0. And then you have y equals negative 4. So y equals x squared minus 4. So you plug in a 0, you get y equals negative 4. You plug a 1 in. And 1 squared is 1, minus 4 is negative 3. Put a negative 1 in. Negative 1 squared is also 1, minus 4 is negative 3. So then we go over 1 down 3, and back 1 down 3. And so then, let's see here. So then we just go over 2, up 1, 2, 3, 4. Because if you plug a 4 in, 4 squared is, no. Oh no, you plug a 2 in, 2 squared is 4, 4 minus 4 is 0. Good, that works. So that goes up like that with our intersection happening. Nice, nice. Domain and range as well, and their inverses? What? Okay, fine, fine. So our domain is going to be, let's see, so negative 4 to infinity, because we're going from negative 4 to the right forever. And then the range will be 0, 0 to infinity. And then the inverse will actually be, the range will actually be down there at negative 4. Right down here, negative 4 to infinity. Good. And then the domain will actually be negative infinity, positive infinity. Wayo. So hinge, you're going to have to restrict the domain of the function. Yeah. So go and try number 50, and that's how you do 49. So you try 50 on your own. Thanks for watching and learning how to do inverse with me. Woo! Switches the x and y, solve for y. Thanks for watching. Bye for now. Bye for now.